Hi everyone. So we're gonna go ahead and redo this problem. The previous problem I just did, for whatever reason, did not record sound correctly. So we're gonna go over this problem that it's a type that uses either an array or an array list plus an open-ended question. This is one that will be administered today, May 6th, on the College Board YouTube page for AP Computer Science A. So the first thing you want to do again, if you have a big enough screen, make sure you can, it might be easier to have things side by side. Some sort of system where you have awareness of the time, your solution, and the problem statement. That would be best case scenario. If you don't have a way to see the time while you're typing your solution, please, use some sort of timer, maybe your phone, so that you have to submit. If you don't fail to submit, there's going to be some issues. You don't want to fail, right? So ahead of time, you should just create a brand new Java project. Um, the exam day, just an empty Java project like that, and then you can go ahead and create a class. Question one, that's going to be your location for kind of typing out the solution, right? So you don't want to use Eclipse to make it compile because there's so many things that you need to have in order for it to compile. You don't want to sit there and try to like make the entire thing functional. Remember, that's one of the reasons I removed the auto grader from the FRQs, because that's not the point. The point is you get the majority of the algorithm, whatever you're being asked to do. You can show it in a way that makes sense to somebody who's reading it. It's not about getting it compilable and runnable. So let's go ahead and get going. So a very typical array list problem will include multiple classes. So typically one of the classes will be the type of objects that you're storing in your array or array list. So in this case, we have a score info. It's a very it's a very typical class. It's just got two instance variables, numerical, they stand for score, the number of students. You've got a constructor where given a score, you can create a score info object. You've got increment, get score, and get frequency. So you got your setters and getters, right? So these just kind of are just your getters and setters. Perfect. So now you have another class. Now this class is going to have an array list of those objects, right? So the reason you need this definition of this class is because of the fact that this thing called stats stores a list of them, and inside something called ScoreList. And then you've got Boolean record scores. So you have helper methods that would add to that list, it looks like. And so now we can get into like part A. So write the stats method record. So I can go here and I know, okay, I need to add this method header just so I know what I'm looking at. Public Boolean record and score, right? So you're just gonna write it verbatim. Again, this is why using an IDE or just using a computer in general to write it is gonna be much faster. Just like that, it's done, right? So now I gotta make sure I know what I'm doing for adding to that list. Records the score in the database, keeping it in increasing score order. So has to be increasing order. If no other score info object represents score, a brand new object is going to be added. Otherwise, the frequency in the score info object representing score is incremented. So there's a couple of situations. If the score already exists in the list, we just have to increment the number of students for that score. If it doesn't exist, then we need to add it, and we need to add it in the right location. And so just to kind of keep things simple, I'm just gonna say, okay, if the list is empty, we just add it, right? So now this is typical of what you might experience. You're like, oh, what was that variable name again? In this case, I had to scroll up and kind of look. The variable is called ScoreList. If it's empty, then we're just gonna add to it. ScoreList.add new score info. So same thing here. Maybe you forgot what it means to create a score info, right? So remember, this thing is holding score info objects. So now you're being tested it on your ability to instantiate objects of any given type. Here, they made up a random class called score info. So I'm just going to invoke the constructor. This constructor call looks for a constructor that takes in one int, which is going to be this one right here. So that's why that would work. And then since we added a brand new object, we're going to return true, right? So remember, it said that anytime you insert a new score object, you return true. Okay. New object added to database. So that's it. If it's empty, we just do that. So now the hard part is if the list is not empty, we have to make sure we're not adding a duplicate score, right? So that means we have to traverse the entire thing, visit every single element. This is a very typical traversal, a very typical loop. So that for loop is going to generate all the possible indexes valid for that list, starting at 0. And so now as we visit every single element, we're going to say, hey, are you the same as the score that I'm trying to add? So let's get that going. ScoreList.get. So now you're making sure that you're showing the readers, the people grading it, that you know that if you have an array list, to read from an array list, you use the get method with a given index. And then, so that's going to give you a score info object. So now we're going to go get score to grab the score and compare it to the score that you're trying to add or update. So if we find that this object that we're looking at index I is the same as the score, then all we should do is update the score. So we're going to do the same thing here, access that object, and then I'm going to scroll up because I was like, oh, I forgot. What was that thing called to increment it? Oh yeah, increment. So remember that oftentimes for these classes, your instance variables are private, which is why there is a need for getters and setters. You don't have access to those things outside of the class without going through the getters and setters. So we're going to do increment. Update score only and return false. So as soon as you find one object that is the same score as the one that you're trying to add, you already know that the list is supposed to be in order and every single element is unique. So you don't need to continue checking if you already found one and you're just going to update it. You can return false right away. Now, the last thing is, this might be the hardest part. This idea of maintaining the order of increasing order. Essentially, if let's say your score is a 75 that you're trying to add, and if you query one of the objects, and then if the object is 76, you know, because it's in increasing order, if there are more elements, they're all going to be bigger than 76. So given that you're trying to add 75, you know that you don't need to check the rest of those things. But what you do know is you need to add at the location where that first number that is bigger than the score that you're adding is. If you add to that location, it's going to keep it in increasing order because it's going to bump everything else, right, to the right, or I guess whatever order you're thinking in terms of your list. So we're gonna go here, check where to add the score. So you're gonna run into either you're gonna find it or you're gonna find a score that's already bigger than the one you're trying to add. So we're gonna go ScoreList.getI. If the score is greater than or equal to greater than your score, you don't need the equality one because this one handles equality, right? So if this is the case, then we're going to create a brand new score object and add it where that current score that was bigger. The first one that you find that's bigger than the current score that you're trying to add, that's where you want to add that object. So we're going to go ScoreList.add at location I, the current score. So here, since you're adding to an array list that stores objects, make sure you're creating that ScoreInfo object, right? You can't just add integers in something that's supposed to store objects of some type. And since we're created a brand new object, we have to return true. Now, because this is a method that has to return a Boolean, under all cases, you have to have some sort of return. So here, we're just going to say return false. If for whatever reason we make it out of this loop and don't make it here, we'll just have a default return. And so that's it. I think, as you can see, this is quite a loaded part A. That's a very big part A here, right? There's a lot going on. We are traversing a list. We are checking objects within a list and comparing with a different value. And then we are altering the list because we're adding to it. So this part keeps the order. This part makes sure you don't have anything identical. And then this part is if the list is empty, then you can just do that. Okay, so now let's go to part B. So again, typically I just go ahead and look at the method header right away because I know I'm just completing a method here. So I can get that out of the way already and just get it out there. Write the stats method records scores that takes an array of test scores and records them in the database. Okay. And then it has to maintain it in increasing order based on the score. So instead of one score now, you have a whole bunch of scores and you need to add them to the database. Guess what? You just wrote, or I mean, even if your implementation of record, right, the add is not correct, you can assume for this part that it's working. And so all you need to do is take all these scores and invoke the record method. The record method is already maintaining order, so you don't need to do that again. So now we're going to traverse a 1D array. I is less than toScores.length I++. So now, it's a very typical traversal. Again, one more time here, we've got length instead of size. If you do end up mixing those, it doesn't matter, right? There's some leniency in this exam where they will still give you credit for that. So now we're just going to do a call to record. Record toScores at I. So here there should be an S. All right, so there you go. I think that really is it. So visit every single score you're trying to add, invoke the record method because that's going to add to our database. And then the record method here is also maintaining the order, as well as the requirement for every single score to be unique. So that's it. That's part B. Now part C. Part C, a programmer would like to add the get senior percent. So this time around, they want to keep a track of the number of seniors that make up a certain score. So for example, here in the table, if you've got a score of 82, the total number of students there are 6, and then the number of seniors are 3. And so we want to be able to calculate the score, which here it's 50% because 3 seniors out of the 6 students that scored an 82 were seniors. So the question is, how can we alter the class so that we can do something like that very easily? So I go up, this could be how you're doing it. So right now, every single ScoreInfo object keeps track of the score, the number of students. But what if the ScoreInfo also kept track of the number of seniors? Would that work? So have the score info class keep track of the number of seniors through an instance variable. And then if you want to be very specific, an integer instance variable. So if you kept track of the number of seniors here, you have the number of total students, um, then you can easily calculate the percentage. It looks like also they mentioned that, record scores might have to change as well, where you need that information whether or not a score is for a senior. But it says you do not need to address these changes in your response. Perfect. It says here also to write the method header for get senior percent method. Okay, let's do that. The senior percent method has to return some decimal number, so that's going to be a double. So public double. The name of it is get senior percent. Okay, make sure to identify which within ScoreInfo any new modifier. Do not write this. Describe for each new revised variable, constructors, or methods how it would change or be implemented, including visibility and type. You do not need to describe get senior percent method. Okay, so here we have to describe the visibility and type. So I said an integer instance variable. So now we just can add that it should be a private integer instance variable, right? So oftentimes when you're designing classes, you definitely do want to try to hide as much data as possible. And that is to limit what can be done with that class, right? So anything else? Visibility. And then so this variable, we can just say that this variable needs to be updated in a similar fashion as num students. Anytime a score is 1 for a senior student. Is that about it? So this one is nice enough that it kind of tells you to make sure that you're talking about these things. Any variables, modify variables, constructors, or methods. Identify within ScoreInfo any new. So now the question is, do you need to add new methods or another constructor? I mean, I don't know. Now I feel like this is a very loaded question. Int a score. So maybe for every single score, um, hmm, I guess potentially you could have something that says increment the senior count. I'm not sure, but that's why they're called open-ended, right? So you're designing something that would fit within that description. So you could potentially have something. You can add a helper method to increment senior count, similar to student count. What was it called again? Uh, num students or something? To the one for num students. So we'll just leave it at that. So for any of these problems, ideally you want to go part A, part B, part C, and then go to the open-ended questions. If you run out of time, again, the general advice is just go through in the order that they appear, A, B, C, etc. So typically, part A had us implement a method, and then part B, we needed to use that method eventually. So it kind of helps that you know how that method works. Although, in theory, you can use that method regardless of whether or not you were able to implement it. And so, worst case scenario, fine, go out of order if you need to. If something seems easier than something else, whatever works for you. But I think the general advice is just go in order A, B, C, and then if you don't get to the open-ended question, so what? Um, if you get the majority of the score, you're still good. And so there you go. So that is going to be the practice question that involved an array list and an array. Thanks.